It's my pleasure to introduce to you tonight one of my previous colleagues in Saudi Aramco, Mustafa Hajjar. Mustafa is a senior enterprise architect with 8 years with working experience in his current role in Saudi Aramco Expat Commuter Center, working alongside the leadership of Saudi Aramco ECC and trying to move them along to the latest technologies. Mustafa has a PS degree in bachelor's degree in computer science from the University of Maryland and a master's from the George Washington University in software management. He has 26 years of experience in technology, working with Fortune 500 companies such as HP, TEPCO, and consultant for Washington, D.C. Office of the Chief Technology Officer. Mustafa specializes in software technology, planning, strategy, formulation, and is responsible for the DevOps and PaaS programs at ECC in Aramco. Mustafa has strange hobbies. He wants to be a private pilot, and I think he used the box. So, if when you ask a question, just keep that in mind. Without further ado, I'd like to introduce Mustafa Hajjar.
Thank you, Zaki. It's very nice to be with you all, and thank you for inviting me. Talking about it, I don't know where those 26 years went, but here we are. Good evening and Assalamu alaikum, everyone. My name is Mustafa Hajjar, aka Captain Moose. And today I'm going to go over introductions to DevOps, basically walk you through our kind of my experience in the past 6 or so years that I've been more directly involved in DevOps back in 2013 to 2000 to the present. Right, so we're going to talk about a brief history and the progression of DevOps, the genesis more or less, talk about why DevOps is such a key plays such a key role in enterprises nowadays, all the business drivers and necessities. Then jump into the basics, talk a little bit in more detail. I'll let you guys be the judge. We can go as deep as you guys would like, or keep it at a high level, but we'll talk about the inner workings and some reference architectures. And from there, we'll move into the state of DevOps worldwide, how enterprises, small businesses, and larger businesses are progressing. Talk about DevOps in the local region, KSA, and open it up for Q&A. By the way, feel free to jump in at any moment if you have a question. And I want to apologize in advance for the slide deck. The template was given to me by a friend. And if you get motion sickness, do let me know that it was too late to change the template. Right, so here we go. So what is DevOps? In a nutshell, it's really a practice. It's an agile practice. So it's not a piece of software or something that a development team claim that they are DevOps without having all the inner workings or all the collaboration with the different parts of application development from inception all the way to release and deployment. So first and foremost, it's a practice that encourages the agility and rapid and frequent releases of software. So that's the first part. The second part of it is heavily dependent on automation. So to make that happen in that rapid and frequent pace, you do need certain tools that allow for automation and certain technologies that we will talk about a little bit later on. Right, so talking a little bit about the history and the timeline of DevOps. So there's nothing radically new, or this is not a certain technology that came out of nowhere or has been invented, or even the practice itself. It goes all the way back from the 80s, back when, not DevOps itself, but the practice or agile practices, if you may. From the reuse of routines back in the mainframes in the 80s, to dynamic link libraries and client server communication, or using that in a client server type of deployment. That all the way through the 90s and through the 2000s, with the advent of web services and web applications being hosted on web servers in production. Towards 2010, and that's kind of the inception of the DevOps practice. It came out of a conference, and it was kind of all the people on LinkedIn communicating about the presentation, and somebody coined it as DevOps, and it caught on. But really, it was talking about all the practices and bringing software development and the operational side of things tightly integrated, and integrating those processes and automating a lot of that. That also around the time where you start seeing more granular web services to microservices that made the decomposition of an application or a piece of software a lot easier. And throughout the years between 2010 and 2020, where we are right now, DevOps as a practice matured more and more, and cloud native became more and more adopted, which strengthens the applications being released through the DevOps practice, and all the principles that I will go over shortly that enables the fast and frequent releases that we will talk about. Containers as a technology came and made the flexibility of deployment and the ease of scaling horizontally a lot more feasible and dynamic. And the introduction of IAC, or infrastructure as code, and obviously public cloud for availing the infrastructure to scale horizontally and even vertically quite fast. Now, what is in store in the future? I will talk a little bit about, will present some trends and the what's called the Gartner hype cycle. But you can see a trend towards autonomous ops and autonomous everything. So more or less, you write the piece of code and it figures out where it needs to go, how big the application needs to be. And there's a lot of artificial intelligence that is already starting to creep in, such as AI testing and artificial intelligence in terms of how you also deploy. I think in the future, maybe towards 2030, you will see developers are focusing more and more primarily on the business requirement and the behavior, the business rule and the behavior application. You will not need to worry about multi-threading, concurrency, and a lot of the different intricacies of how software behave and how it's deployed and where it's deployed and when it needs to scale and what are the different environments it needs to go to. All that is going to be done autonomously through the platform that you are developing in. Right. So why DevOps? Why is it such a big buzzword nowadays and everybody talks about it? It all goes back to the necessity and the bottom line. So when companies are making money and there's a practice that fostering that is where you see the investing. So some of the drivers and the advantages that were able to be achieved through DevOps goes behind business agility. I mean, you all know if you can be the first in the market with a certain service and it's stable and it's looking great, that's where the customers are gonna go into. So business agility is a major factor in promoting DevOps. Innovations, people can just jump in and develop a piece of software and deploy it rather quickly, and all R&D is, in terms of a cycle, has shrunk quite a bit thanks to DevOps and the ability to interact with business, to look like, hey, what do you think of this, and all that interaction. Digital transformation, as I'm sure you've heard, and IR4 and all these technologies are really empowered by DevOps, right? So the ability to develop all sorts of AI algorithms and be able to deploy them rather quickly, test them out, see how The algorithm is working in a real-life application that further promoted the DevOps practice. Quality, given that you can get repeated testing, repeated behavior over and over and over, and fix all the bugs or intricacies around the way the software runs, you're able to achieve that because you're automating all the testing or all the quality controls automatically. It's no longer dependent on humans running tests and doing regression, not just regression testing, even on the functional, non-functional testing. So there's always a certain level of error there when all of it's being automated. Your quality, including from a security perspective, is increased quite a bit because of DevOps. Closer collaboration. I don't know, for the older developers in the crowd, business is another company, right? So you barely see the business development people or the marketing people. All you get is a piece of in the past, a document, whether it's a software specification or requirements, and you work through that as a developer, and you're really not interacting with the business people or the ops, for that matter. It's everything siloed in those vertical kind of business functions. So DevOps brought all these people together, part of the way it runs, and businesses started collaborating and figuring things out a lot sooner than before. Even I see in some companies, accounting are involved in this, the auditing are involved in certain cycles. So you get this closer collaboration across the business, which is very good for the business. Obviously, the last one is the fast delivery. You're able to build something, deploy it, and be the first in the market with that service. And the fact that you can create granular services and add a small feature to an existing service, that helped a lot. And the people that benefited from this the most is really telecom. Telecom were kind of the early adopters. They were able to put up different packages for customers that, you can add more minutes or do whatever, or sign up for this service, and that's all enabled by being having that kind of offering to the customer very early on and beating your competition to the punch. So all in all, these are just the highlights of the advantages and the drivers that led businesses to want to adopt DevOps, although not many enterprises, let's say, has successfully implemented it all the way in its true form. Again, if you guys have any questions or anything, please. I guess I don't see a hands up, so you can just shout it out. I'm looking at one screen. Right, next, this is something that is becoming more and more adopted in enterprises, and this is a framework around that's brought in from Gartner. It's called the DevOps Value Stream, management platform. And what it does, it's kind of organizes customers' needs and ideas from inception all the way to a customer value, and hence the cost or the money, the bottom line, in a very organized and kind of repeatable, monitored cycle. So it goes from the ideation or the business road mapping to planning everything, integrating and verifying all the services together, deploying and operating, and providing all the monitoring and improve upon the service, all within the kind of product delivery pipelines. We'll talk about products versus projects a little bit later on, but keep that in mind. It's a very key concept that businesses are adopting nowadays. And after that, you get your customer adoption, satisfaction, and you continuously loop that feedback into this platform that results in what you're calling a continuous delivery. So that's, in a sense, the main drivers from a business perspective behind DevOps. Now let's talk about the basics. At the end of the day, it's a practice, and the practice goes, touches on the people, the skill set. That is one of the main challenges nowadays. The processes, what needs to be integrated and talking together from an end-to-end single process. So no longer you have the business and the ops processes and dev processes. They're all intermingled and automated, and that's done through the tools. So looking at the key components from a high level, these are some of kind of few of kind of a bit of each from a processes perspective, people and tools. So for developers and ops people to adopt any certain technology or practice, they need training, they need support, they need the best practices. Businesses have to avail all that. They cannot say just, we're going to start doing DevOps. You really have to plan this whole thing all together. The tools, you need to look at your tool chain and pick your tool chain quite carefully and adapt that to your business, not your business to that. So as you know, there is a plethora of different tools when it comes to DevOps, and they are changing, on a monthly and daily basis, and in terms of popularity. So you have your continuous integration, continuous deployment, which is becoming now more around continuous not a continuous delivery, which is morphing into continuous deployment all the way to production. You have your automated testing, the pipelines that I just spoke of, infrastructure as code, and all the tools that allow you to deploy a certain piece of software in a container in a certain target environment, and the different target environments, be it the key flagship cloud services, Microsoft or Oracle, or the different Amazon, and so on and so forth. Also, the adoption of self-service platforms. So developers are getting access to all these tools in a self-service format, where you can say, okay, I want to develop this kind of application, and I want this type of service in terms of testing, deploying on this kind of VM. My customer, is looking for Windows containers, for example, and so on and so forth. Change management, and I want to add to that just management of change. Management of change, you have a lot of people with different backgrounds in terms of where they worked before and how things were done, and they resist the change a lot. And there's a lot of management of change from a process perspective, and that, as you know, happens only from the top down. Management really have to buy into this to the core in terms of opening up all the different silos and saying, from now on, you have to work horizontally, work close together, and being a champion of that change. Change management in terms of release and just the change management function, which typically in classical enterprises tends to be a more rigid function focused on making sure production is always at a stable state. And it is part of the ops part of the house, and it's always been a big pain to get changes into production. And that sometimes takes weeks in preparations, and especially if you're running a big service. With DevOps and the tools that are implemented and the automation, all that is really streamlined, and you can ensure the quality and the stability on production through different release mechanisms, be it canary releases or chaos engineering, and all sorts of things that ensures that you still have a stable production environment without having to go through all the rigors of change management. Governance, whether it's security, architectural, or audits, in terms of government compliance and policy compliance, that is also made sure through testing, and it needs to be incorporated into the pipeline. As you know, governance as a function puts a damper on things. You got this cool software, you want to go to production, and security guys say, whoa, 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 wait a second there, big shot. So involving these guys, whether it's from compliance, from security, or enterprise architecture, or the architecture side of the house, into automating what they're looking for in terms of what's called just enough governance. So what do you need to get the software to pass through? And the engineers and the security working together hand in hand, or compliance or enterprise architecture, develop these kind of templates or compliance packages that ensures that software meets that on its way to target environments. So that's a key component part of from all aspects, the process, people, and tools. Metrics, something cannot be measured, cannot be improved. So early on, you have to identify the different DevOps metrics, all the way from idea inception all the way to the end, where you look at customer satisfaction related to such release. Not only customer satisfaction, but internal as well, with the developers and ops and all the different people, in terms of how every release is going, or the product development is going. So metrics is a key factor, part of DevOps, because you want to track it, you want to make sure that you're improving, see what you're doing well, continue it, what's not doing so great, and fix it. So these are the primary components, although there are few more, but these are the only I was able to fit on the screen. So the DevOps cycle, going back to kind of peeling the onion and looking at software release. I'm sure we have software developers on the call, and nothing is inherently new. You always plan your release, your application based on the requirements. You coded it, you build the code, you test it, released it, and operate it. Now, what's different over here is the repetitive nature, or the fast repetitive nature, and all the tools that are, I mean, there's all sorts of tools, and even this graph is probably a year or two old. A lot of the services has been updated, and you got newer technologies on the market. But the iterative nature of it, and doing that on both dev, test, and prod repeatedly, and with a push of a button, that's what DevOps, or this specific cycle, is changed from the past. And you can't talk about this without talking about container and cloud native. We'll cover cloud native in a second, but but looking at development and how the cycle kind of a step by step is going. This is after the kind of the idea is formulated, and collaboration with the business people is conducted. A developer starts with the coding, and from a pipeline perspective, we're talking a little bit more about the pipelines over here. Once the code is committed to the code repository system or versioning control system, that triggers a pipeline that takes that package from whatever branch it's at, and based on the rules and configuration of that pipeline, it does all the related tests on the related environment, whether it's part of the build and what have you, packages that up and pushes it on whatever target environment, be it integration, testing, or another development environment, or all the way to production. So in this case, let's say, you're building everything and you're using infrastructure as code to build that container, put it together, and send it all the way to production, otherwise known as continuous deployment, right? So that goes through containers all the way, and these pipelines, to the operational environments or the infrastructure, wherever you're hosting or deploying the containers on, be it cloud, private cloud, and what have you. And over there, the pipeline and the supporting tools would know which containers are behaving and which are not, and the ones that are in the target environment as well. And if a container is not behaving or not running, given the immutable nature of this environment, it will just close out these containers or features or services and send them back, or notify the developer team that this has failed, figure out what's going on, and access to all the information they need to get that. There's a lot of tools that enable that. A lot of the stuff that you're looking at is, again, outdated, probably a year or two. There's a lot of newer kind of software. Some of them are still being used. And that's one thing common about all these DevOps support tools, that they're constantly changing. You get more and more open source project, which made it more feasible to the smaller businesses to adopt. And they go up and down in terms of project popularity and usage. But this is kind of a flow of how DevOps and containers are built and pushed to deployment. You're talking only primarily on the technical aspect of things. Right, so to develop applications nowadays that kind of makes the best use of all that, you want to implement cloud native. Although there are people that are doing taking the whole monolith application lift and shift kind of deal. So they take an application as is with, this big monolith, as they call it, and they can deploy it into container and send it out. But every application or piece of software needs to have certain characteristics or principles and patterns that it needs to abide by to be a truly cloud native application. And that goes, there are 12 factors or principles that are predominantly kind of popular nowadays that ensures that if the software has all these characteristics, that it's flagged as it is a cloud native piece of software. It goes from ensuring it has all the it is part of code base. So all the revisions and the branches and the trunks everything is being tracked. And that's how the software is built. Tracking all the dependencies, be it through software like Nexus or similar dependencies, are all explicitly declared. All the configurations are specific to every environment. So in the past, we all know, I'm not sure if you guys experienced this, but you run an application and test, it's running fine, it goes to production, it craps out, everybody spends 2 hours trying to figure out in the middle of the night what the heck is going on, and you find out somebody put some hard-coded tag somewhere in a config file that's pointing to a test database or test environment thing that is breaking the production release. So configs have to be dynamic based on whatever environment you're targeting to. Backing services, your databases and messaging systems, all the back-end services, if you may, are attached as resources to their URLs. So they're considered kind of decoupled from your software. It's very different than the way that we used to connect to databases in the past. And so your software is not at risk of that tight coupling. Build, release, and run, basically making sure that these are strictly separated in all stages. The processes, and that's very key. And if you remember from web applications in the maybe 2010 and earlier thousands, you do something and your session times out, and all of a sudden the whole system is going crazy. So everything has to be stateless. Whether your session times out or not, you should be able to go get back, or the user needs to be able to get back to whatever action or feature they've been accessing without encountering errors or a state-dependent situation. Port binding, every service needs to be encouraged to have different port binding. And from a concurrency perspective, obviously, all the multi-threading aspects of an application of all the different services, and that would facilitate scaling horizontally quite a bit, and treats every container, for example, service running in a container, as a piece of software that you don't care if it falls or not. You can expand it or kill it without incurring any problems on the core system. Next is disposability, which is kind of what I touched on. You need to have the ability to kill off services, have them gracefully shut down without breaking the system again or the overall system, and have them more or less being immutable. So it's gone, nothing's going to happen. You can bring it from scratch all over again, and everything is hunky-dory. Dev prod parity, and that is something that we struggled with in the past. I remember days where you're constantly trying, and there's all sorts of products that don't come close to allowing you to do this. Keeping the state the same in the development, staging, and production. Once things are not mirrored exactly, you start getting different behaviors and your software starts acting differently. And thanks to containers, a lot of this is brought down to, it's becoming negligible, apart from the data, of course. So your system state is the same regardless of the stage, but that's very important to have this dev prod parity. Logs are a very important aspect of every software developed. You need to be able to trace and all the logs and everything, the behavior, and monitor the application through part of it through these logs, and treating these as event streams that are coming on the pipe, and having them accessible at all times to different people. Admin processes, and that is if your system is hanging or halting for whatever reason, everything is running on its own separate process. You can introspect into what's going on, and without being tied down to that same thread, and so on. Any questions on cloud native before I move forward?
I'll ask a quick, give you a break, Mustafa. I'll ask a quick question.
Go ahead.
So is API part of these 12 cloud native factors? Can we say that your application needs to export all services as APIs? And which one is that? Is that port binding?
Well, if you think of an API, it's a small service, right? So it needs to have all of these, right? So that small piece of code, which is exposing the functionality through this API or RESTful API, needs to cover all 12 aspects of this. It needs to be, part of a configuration management system. It needs to spit out logs through the event stream of what it's doing. It needs to have all the if it's using, for example, a database or a backend system, it needs to be bound to it in a loose coupled way. So yeah, it does cover this to its entirety. Depending on the service as well, or that API. So to consider that API or collection of API as cloud native, they have to have implemented this capability or these factors, principles.
Thanks.
Sure. Right. So I mentioned earlier that everything is now treated as products. So when you come up and you develop, let's say, these APIs. In the past, whether it's, you ran a project and we were very tight and treated the scope as this thing that cannot be changed and it's written in stone and you'll get the end product in about a month or 2 or 3 or whatever, that is all going away. And there's project management is seldom done in the same old-fashioned way. Now you have products. So whatever your software does, whether it's order for fulfillment on the web, that is considered a product, and every new feature or minimal viable product, small feature or a bunch of APIs to do a bunch of functionality is treated definitely at its own small kind of component throughout the entire cycle. And you introduce different features continuously, and you're no longer going through project and project scope, but you're working collaboratively with your business people and introducing certain functionality, and those MVPs go through the entire cycle, and that could go as little as in hours in some high profile businesses, or even or days for more normal businesses. Okay, for example, you've noticed in all these apps in the recent year, I mean, the Kingdom is, the guys here have been doing a great job with all the features introduced in the pandemic applications, whether it's the Wakkalna or whatever, and every time you open your phone or a few days, there's a new update, there's new feature, there's new functionality. You cannot have done that in the 2000s or the 90s, or even, I can, you know, argue 5-10 years ago. Mainly because everything is not considered as a project, but as a product that you can add small plugins, not plugins, but add small features to it, or what's called minimal viable product. Design it very quickly, code it, build it, test it, deploy it, and so on and so forth. And through these main phases, the continuous integration as far as the software and software build is concerned, the delivery, and the entire cycle is called continuous deployment, and obviously the continuous quality and monitoring. But this cycle, through this kind of change in mentality and process from a project-centric software development to a more product that you continue to add small pieces to it nonstop. Some of the approaches that enterprises are taking to introduce, I'll talk about this, and I guess we'll move on to the reference architecture. It's as I mentioned, because of the different aspects of people, processes, and tools, it's a drastic change to companies and enterprises that are not familiar with it. And the reason why I bring this up, probably a lot of you are either part of an existing enterprise or will be part of an enterprise, and they have their internal kind of culture, and things are harder to adopt versus smaller, nimble companies and startups and what have you. So, but they need it nonetheless. They need to stay competitive. They need the agility. They need all the benefits that we discussed earlier. So how do you do that? Well, this is a common approach, what people are doing. First of all, called the bi-model approach, and that's, you know, leave your system, everything that is running the way it is, keep it as is. Don't mess with that. Don't go through big migration, and we're going to adopt, you know, DevOps and refactor all the applications and use containers. You know, you hit the wall there. But pick certain applications that fit the profile for kind of high decomposed services, or just mini macro, whatever services-based type of business function that you're willing to adopt the DevOps and cloud native containerization and cloud through that. So you have the first mode, which is your business as usual, and another mode specific with different tools, different processes, different compliance tracking, different type of security to a certain extent, and run it through there. So that has been adopted quite a bit. The usage of containers and cloud has been, it fosters the kind of achieving DevOps. So it's a lot easier. You can argue that you can fit kind of a circle in a square and deploy using DevOps to a traditional client server application, but it's really not feasible that way. So people also are adopting containerization and cloud a part of this whole change. Obviously, cloud native fosters both, so you're able to follow the DevOps kind of practice and deploy all your services into containers on the cloud. And last but not least, and that's kind of self-evident, and being able to do everything phased and iterative and measuring everything as you go along. So these are kind of the four main characteristics that people or enterprises go through to introduce DevOps as part of their capability, right, in developing software and what have you. Sorry about the background noises over here. Right. So a common reference architecture that I've seen and worked on in the past is the recent past. Um, Having all your development, all the different suites and tools that developers need, all incorporated in a part of the cloud, more or less, right? So you're giving your developers the ability to access all sorts of open source software in a kind of a managed environment, whether it being through what's called artifact scanning, and access to all sorts of open source, whether from GitHub and what have you, to give them the flexibility to implement all sorts of innovations. But you need your IDEs, your test suites, profiling. You need to go through what in the past was the application lifecycle management, and that's more kind of the DevOps cycle, where you access developer-centric services, whether it's open source, software configuration, team collaboration, and use all the different APIs that you have, whether it's part of an internal gateway or they're just available on the network, including data services, integration with different systems that you have, and any other internal services. And having that accessible. Commonly, a lot of people have these components already part of a cloud. So everything goes, let's say, from right to left through the CI/CD tooling and all the automation over there, all the way to your runtime environment. And that could be your test, regression testing and integration testing, your staging or user acceptance testing, or actual production. If you have pipeline that do the whole continuous deployment scheme that allows software to go from the developer all the way to production. And yeah, so this is a typical kind of a reference architecture at a high level. But you will also see dug out in the past some reference architectures from major players. I have one here from Adobe, and how they're running the, probably familiar with the Creative Cloud, and they're offering over there. This is some of the pieces of the puzzle that they have over there. You can clearly see they're using a lot of cloud. Cloud is becoming, and cloud projects, open source software is a must. Nobody develops software without that nowadays. That was not the case 6, 7, 10 years ago, or even 5 years ago in some places. But you'll see that more and more evident, and artifact management and repositories is becoming more and more a requirement in every business. Another one, and I'm sure this is outdated, the PayPal continuous integration and using the hybrid cloud between their internal private cloud and public clouds, using services from different parts of the business, building everything and deploying it on infrastructures globally all over the world. It's not very clear, but you can see the core components over there, whether it's artifact management again, Dockers in different places, and managing different clusters using Kubernetes and what have you. Right, state of the DevOps. I'm running out of time, so I'm going to go a little bit faster. There is, first talking about the trends. As you can see, this is as recent as July of 2020. And the key technologies that we're hearing more and more about is continuous quality. You see a lot. I talked a little bit about the DevOps value stream platform. Chaos engineering, that's another thing that is being adopted to introduce higher resilience. You have chaos engineering here somewhere, I'm sure. I'm trying to artificial intelligence for IT. I talked about that part of the future. Continuous compliance automation and the programmable infrastructure. This is kind of automating AAS, which is the infrastructure as a service. Immutable infrastructure is very key. And so these are kind of the trends that is going up. These are the trends of the past that are not a big, not that they're bad, that's they're not hyped anymore. The DevOps tool chain. And when you get to the plateau over here, these are the things that are adopted. So when they go down here, they're either are not adopted. People did not kind of came as a hype and did not catch on. So they became obsolete and no longer. But the ones that do bring in value, they come into the plateau and people start using it as continuous configuration automation. Spoke about earlier, agile DevOps and agile ops, sorry, and things of that nature. But this is kind of what you over here with your future. Some of this will make it, some of it won't. We'll just have to wait and see. So back to the report, the Puppet and the collaboration of a bunch of other companies, they released this annual report called State of the DevOps report. And it focuses on what the highlights, how organizations are evolving in their use of DevOps. One of the highlights is this kind of expansion of DevOps beyond IT and into the business, as I talked earlier. And businesses, in some places, DevOps is an business initiative where they're we want to reach agility. We want to be able to do such and such like this and that company. And we've heard that the way to do it is DevOps, and we want to bring that in. And you will see different functions of the business starting to become part of the overall DevOps process and practice. Another one is scaling DevOps through internal platforms. In the past, as I mentioned, and continuously, even to this day, you have numerous open source tools, automation, and all sorts of development aid tools. And that integrating that continuously is kind of a function by its own. Making sure that everything is operational across the organization and integrated is becoming more and more of a pain in the past couple of years. So different vendors kind of got onto that, start implementing these platforms. And some of them are even internal. So the developer only has to worry about, or the ops person, what's the platform is providing them. And that goes from, your CI/CD workflows, infrastructure, cloud infrastructure, development environment, monitoring, alerting, all these functions are becoming part of the platform. So there's a lot of adoption into these DevOps platforms. Another highlight, as I talked earlier, around change management. In the past recent years, they realized that the rigorous change management process is bogging down the process and making the business less nimble, although you can still maintain the stability of production on the service you're offering without having to go through all the manual and rigor that past change management has been doing. And so they're starting to come in more and more to the mix and automating a lot of their kind of checks and balances for ensuring stability in production and change in general. All change requests are done automated for the most part, and that enables you to do the continuous deployment all the way to production. Another one is around security and security integration in the past. So no longer these guys are kind of blocking the door to production, although there's a lot of security risks and concerns, but more and more they're becoming part of the overall integrated process. And companies that have adopted that and really baked it into their DevOps cycles have seen that they've been able to address even security issues when they occur a lot faster because they're part of the process. They're injecting everything and they're able to remediate in a short period of time. Lastly, they also came up with a kind of a maturity model, and they did it kind of along the lines of your typical CMM or from a model perspective. you will find a lot of the organizations fall around the first and second stage of this evolution. They have their practices in place, they have some standards implemented, but exploring and being able to adopt different patterns has been more challenging than the past. The automation and delivery, also people are not just there just yet, although adoption in more and more cloud is enabling this. But you have different enterprises are able to achieve certain aspects of every stage, but not the full. So that's the maturity model as a whole that was introduced in 2020. Right. So in the region, from did some research. Some of them, you'll recognize some of the names. Although I know Emirates is in the Gulf, but I just wanted to go over their case study, and then we'll talk about the more local ones. Recently, I attended an innovation lab hosted by Red Hat, and Emirates is a big customer of theirs, and they did a big port of their infrastructure and services to use AWS in conjunction with a lot of Red Hat products. And overall, they ported a lot of what they're doing in the infrastructure onto AWS, and used a lot of their services, their offered services, and baked that into their DevOps kind of pipelines. And from what's documented on this use case, they were able to drastically reduce time to market on the different the kind of service, ticketing packages and what have you. When they did all that, they had zero downtime through practices, deployment practices adopted through DevOps, and they had a decent improvement of their booking system, which is, you can do everything in 12 seconds, and they're counting that. So as far as local implementations or adoption of the DevOps practice from tools and everything, a lot of work is being done by, I've heard of a bunch of work through Kewa, working with Takam on a lot of the e-services. A lot of the government contracts are filtering into smaller organizations that are able to come up with fast solutions or services utilizing DevOps. Kewa, you hear the name Kewa quite a bit. Bank al Bilad, they're adopting Kubernetes, for example, and the way that they're deploying, or their continuous kind of the deployment function. From what I hear, they're not as successful at it, but they're working through it. But they're adopting the DevOps practices and containerization as well. Tika is a place that you keep on hearing. They do a lot of good work. They've done, I think, all the way back from Souk, and a lot of new systems or services being implemented by this company. And the guys there, they see rigor, they adopt, from what I understand, DevOps quite rigorously, making sure their pipelines, are. It's very important that the pipelines are always running. Even if they break, they have to be corrected or fixed right away. So they're abiding by a lot of also the cloud native patterns and what have you. Hunger Station is also a big operation that has adopted DevOps. I know somebody there that talks all sorts of things about how they implemented Kubernetes, and being able to run pretty much everything, a lot of stuff in open source. They're using the open source Kubernetes, or the Google based one over there, and they've been able to do it successfully. There's a lot of work in terms of DevOps in SDC, but quite honestly, I spoke to somebody that I used to work with, and they said some of it is true, some of it is marketing, but they are starting to dabble with it, like a lot of enterprises, but that was from a year ago. I'm sure they've advanced a little bit more. NAGIS is for all the real estate kind of government service. And that is all Kubernetes, and it's a small team that are running this whole operation, and they're all running all their DevOps tools and practices across the business. And that's another success story when it comes to DevOps in the region here in the US, UK. KSA. Right, so that is it. Sorry, it took a little bit longer, but than I anticipated. If you have any questions, please feel free.
That's great. Thank you, Mustafa. Thank you. It's a great presentation. Any questions from the floor?
Yes, Mustafa. First of all, thank you very much for this great presentation. I want to ask, if somebody wants to start his career with DevOps, where should he start?
Very good question. I recommend strongly getting yourself equipped with the necessary training, and you have all that available online, right? Be familiar with all the tools. Follow certain projects on GitHub. Be very comfortable in developing applications following the cloud native paradigm. Think with things on your own, right? Get yourself a free container, whether it's on Google Cloud or Azure, although Azure is a little bit expensive. AWS are reasonable, and just tinker with it. Build a small piece of software, follow all these patterns, and deploy it there, right? And research a lot of some of the you can use Jenkins for your CI/CD, the free version of it, and you have a bunch of freeware automation testing. Start getting familiarizing yourself with all the different stages. At the end of the day, it's not something kind of like I said, a new invention. It's really software development as before, but being able to work in an agile manner where you can build the code, rather small pieces of code, microservices or mini services, deploy them rather quickly, getting yourself familiarized with the different stages of the deployment. There is an article by Gartner a while back talking about something, and they come up with all these weird coin names, but it's called digital dexterity. And what is interesting about that thing is that being technically good is not the only thing that allows you to contribute to a business, a team in some company. You have to be able to work as a team. It's all about teams, right? And understanding what different parts of the business kind of does, if that makes sense. So you need to understand, okay, what the businesses care mostly about, and be able to communicate and collaborate that way. You can't really kind of train for that, but keep that in mind. But yeah, like I said, short answer is start building things yourself, start tinkering with different things, start dabbling with all sorts of AI services being offered out there. AWS, Azure has a lot of them. Learn about their inner workings and add that to your resume of things that you know.
Thank you. Clear.
Sure.
Any more questions? Well, I think this is 8 p.m. So if there are no more questions, we're right on the money.
I have a question about Docker Swarm. It's still anyone using it in production?
Sure.
Right. So we're primarily, quite honestly, a bit weak on that side, but we've adopted more of the Red Hat version of Kubernetes in production. I don't have the details. Kind of sorry to explain that, to talk further in more depth about that.
I can speak about it. So, what's your question about Swarm?
It's reliable to run Swarm in production.
I think yes, it is. But Kubernetes is both of them. Kubernetes and Swarm are container orchestrators. But Kubernetes is much sophisticated orchestrator than Swarm. I would say I would use Swarm for small production environments, and it can manage Kubernetes or containers easily. But for bigger one, definitely I would go with Kubernetes.
Okay, if we rely on the Docker virtual network to communication between the services, this will make an issue.
I'm sorry, say again the question. I couldn't hear it.
If we're using a Docker network to communicate between the services inside the Swarm, it can handle a lot of requests.
Yes, it can. Again, if you have a small amount of containers, it's perfect.
Okay. Thank you.
If I may go back to the previous question, you'll find there's to improve your kind of skills in the different in DevOps and beyond. There's quite a few practitioners. You always want to really listen to practitioners, people that have been kind of using it and practicing this DevOps and containers and everything. Martin Fowler is a big name that you see there everywhere. There's Mike Pfeiffer that has open sessions on YouTube, and he's very well renowned. And there's a lot of people that you want to follow, you want to learn from. So definitely, that's something I missed to discuss. So follow the practitioners.
Okay, thank you.
Sure.
Any more questions for Mustafa? Well, if not, then thank you very much, Mustafa, for joining us, Geeks Club, and this was a great presentation. Thank you for your efforts, and thank you for everyone that attended. I believe Ali recorded the session, so if anybody wants, I think Ali can provide him with a recording, somebody in case he didn't attend. Is that all right, Mustafa?
Yeah, that's fine, of course.
Sounds good. Thank you very much, Mustafa, and best of luck. We'll talk later.
Thank you, guys. It was nice talking to you, and thank you for having me.